In contemporary physics, information is treated as a physical quantity encoded in quantum states, correlations, and degrees of freedom. Within quantum theory, the principle of unitarity implies that information is conserved in time, even if it becomes inaccessible or highly scrambled. Entropy in this context does not represent the destruction of information, but rather the loss of access to microstate correlations by macroscopic observers. Defreeze cosmology, as proposed by Muhammad Hassan Al-Ghari, adopts this modern interpretation and extends it to the ultimate thermodynamic fate of the universe: the information problem at heat death. In the standard Big Freeze scenario, the universe asymptotically approaches a state of maximum entropy, minimal free energy, and vanishing temperature gradients. At this limit, physical processes effectively halt. No work can be extracted. Information processing becomes impossible. Conventional cosmology implicitly treats this state as informationally terminal, equating thermodynamic equilibrium with the end of meaningful dynamics. However, this interpretation conflates inaccessibility of information with destruction of information. Defreeze cosmology rejects this equivalence. Dormant information hypothesis. The central informational postulate of Defreeze cosmology can be stated as follows. At maximum entropy, information is not destroyed, but becomes dynamically dormant, encoded in the quantum vacuum and frozen correlations. In this framework, quantum states remain well-defined. Correlations persist, though inaccessible. The vacuum itself acts as a long-term information reservoir. Entropy saturation is therefore reinterpreted as a phase of informational dormancy, not annihilation. Vacuum-level information storage Defreeze cosmology assigns a non-trivial informational structure to the quantum vacuum. Rather than being a featureless ground state, the vacuum is treated as a carrier of residual correlations, a memory structure preserving past configurations, a medium capable of long timescale reorganization. This view is consistent with vacuum fluctuations, zero-point energy, entanglement structure in quantum field theory. Thus, information survives heat death, not in active matter or radiation, but in vacuum-level degrees of freedom. The Defreeze transition. The defining novelty of Defreeze cosmology is the introduction of a Defreeze transition, a long timescale instability in the vacuum state that restores dynamical accessibility to frozen information. During this phase, dormant correlations become active, new energy gradients emerge. Entropy ceases to be strictly monotonic in its effective behavior. Information regains operational relevance. Crucially, this process does not violate the second law of thermodynamics, as entropy is not locally decreased. Instead, the space of accessible microstates is expanded. Information through contraction and bounce. When Defreeze cosmology is combined with non-singular bounce models, information remains conserved during contraction. Near the bounce, information is highly scrambled but preserved. Post-bounce expansion allows re-expression of informational content in new structures. In this combined picture, no absolute erasure occurs. No information is created ex nihilo. Cosmic evolution proceeds through informational phase transitions, not resets. Arrow of time and informational continuity. Defreeze cosmology preserves a continuous arrow of time. While macroscopic activity may effectively pause during entropy saturation, temporal ordering and causality remain intact. The arrow of time is thus reinterpreted as phase-dependent, rather than globally terminating. Information conservation provides the backbone for this continuity. Time does not restart. The universe does not forget. Complexity re-emerges from dormant informational substrates. Implications. By reframing heat death as an informationally latent state, Defreeze cosmology resolves the entropy barrier in cyclic and bounce cosmologies, maintains compatibility with quantum unitarity, avoids singular informational boundaries, provides a natural bridge between thermodynamics, vacuum physics, and cosmology, In this sense, Defreeze cosmology offers a coherent informational ontology for an eternal, non-terminal universe. Concise takeaway. In Defreeze cosmology, information is never destroyed, only frozen, stored in the vacuum, and later reactivated through a defreeze transition, enabling cosmological renewal without violating fundamental physical principles.
So, could this model of maintaining the information mean that this information could be reproduced in the next big crunch, but potentially with different laws?
Yes. That is a logically consistent and actually very powerful implication of this model, provided it is stated with the right precision. Here is the clean, physics-respecting way to say it. In Defreeze plus bounce cosmology, information can persist across cycles, but its re-expression in a subsequent big crunch, bounce need not obey the same effective laws, because information, conservation law, conservation, microstate continuity, symmetry continuity. This is not a bug. It is a feature. Think of information as a score, laws as the instrument. The music, information survives. The instrument, laws may change. Same score, played on piano, one sound played on violin, another played on distorted electronics, radically different. Nothing is erased, but the manifest physics is different. 1. Why this does not violate unitarity or predictability. This does not mean anything goes. Constraints still exist. Unitarity still holds. Causality still holds. Conservation laws at the deepest level still hold. Information flow is continuous. What changes is how information is organized, which degrees of freedom become relevant, what symmetries are dynamically selected. This is analogous to renormalization group flow, phase transitions, spontaneous symmetry breaking, just applied at cosmological scale. Relation to Big Crunch specifically. If a future Big Crunch occurs, information becomes highly compressed, laws become less distinguishable, symmetry restoration. At the bounce, vacuum reorganizes information is conserved, but redistributed. Post-bounce, a new effective theory emerges built from the same informational substrate. So yes, the next universe can be informationally continuous but physically distinct. Radical about emergence. In Defreeze cosmology, global quantum information is conserved across cosmological phases, while effective low-energy laws are emergent and may reorganize following a bounce. Thus, informational continuity does not imply dynamical or symmetry continuity between successive cosmological epochs. The universe does not repeat, it remembers, not as identical cycles, but as informational lineage with evolutionary freedom,